1 minute preparation with the cue cards and then a 2 minute speaking period. I'll skip through, and this is where you actually record your response. This is the result page. You see that you have this overall speaking band with your practice score. You have a lot of critical metrics, and then you have your rubric scores. So here is where we have the fluency and coherence rubric, your band score on that exact rubric, what your strengths were, and it also shows your areas for improvement. At the end, you can find the annotated transcript. It is built with Python and the API was exposed with FastAPI. The overall process is I first took the audio and ran it through Whisper and then did a WAV to VEC2 analysis to extract out the filler words. Of course, with Whisper, if you tweak the model correctly, you can get the fillers out of that too, but it's not 100% accurate and the obvious fillers are shown, not the subtle fillers. So for the subtle fillers, I used WAV to VEC2. After step 2, we have a full transcript of the words and also the filler words. Then we go to step 3, where I used Whisper alignment to align the words to proper timestamps so that I can understand where the speech was paused, where it was ended, and also the overall flow, words per minute, and so on and so forth. And of course, using that, I can build up the whole transcript using the filler words from the WAV to VEC2 and also from the original Whisper transcription. After that, I ran it through a lot of different processes to understand the pauses, to understand how the speech was flowing, understand the words per minute, rolling averages, and so on. And with all of those, I can use some weights to different parameters to get overall a fluency score. At that point, I had a fluency score which was consistent. I tried a lot of samples, and for all of the samples, I thought that the fluency scores were very relevant. After that, I thought it can be expanded onto an IELTS speaking scorer, because in an IELTS speaking we have the 4 rubrics, and the 4 rubrics are clearly identified in the IELTS guidelines, and I thought that we can use those guidelines to guide us into understanding the rubric scores. Of course, pure code can only get you so far. I had a lot of data regarding the pauses, the variance, the progression of the words, progression of speaking, but I also needed a lot of data regarding the grammatical errors, the vocabularies used, complex or simple sentences that were used. Initially, I thought about using a deterministic system like a Python library that can extract the grammar, but that was not very good because in speaking we don't always have the most accurate sentences, although on paper those can be constituted as a grammatical mistake, but actually when speaking, when hearing, those sound fine. So I knew that I had to use LLM, but I know that LLMs can be non-deterministic. So to reduce that as much as possible, what I did was I did a prompt to extract deterministic elements out of a transcript. For example, a list of the grammatical errors, a list of complex and compound sentences used, and so on. I used GPT-4o Mini for this with structured output. That means I would get a predictable format of the result, and then I used those along with some weights to calculate the actual rubrics. Along with some tuned prompting, we had a system that could extract the rubric scores, but we also had to tune the weights to get the exact values out. So I extracted a few IELTS speaking performances with their scores. I made sure that the ranges were very broad. So for example, the ranges started from IELTS score 5 until till IELTS score 9, and of course we don't have any official samples for those, so I extracted some out of YouTube. If my scorer popped out a band 7 on a band 6.5 that was written on YouTube, I thought that that was acceptable. And that way, after a lot of tuning, I had this system that could generate band scores along with specific rubric scores. I think the most important thing here is not the exact accuracy of the score. That can depend a lot on the instructors. So for me, the most important thing was to have consistent scoring. If someone gets 6 and if I use the same audio multiple times, it should always output 6, because that way we have a learning journey. Someone can take the feedback from the API and then use that to improve, and when they submit a improved audio, it should clearly understand that improvement and adjust the band accordingly. So after a lot of tuning, after a lot of development, it was actually done, and I am happy with my version 0 result. I have the API published on Rapid API as speech analysis API. I have a complete documentation here, so you can go ahead and scour through that. And I also created a SaaS